let everything away. Uh, no using my car.
So I
You
get
know, I made
I give you guys like
changes.
2 minutes to try this before I go over it. Oh yeah, that's fine.
I made all changes in my life, and so that has, it's
So try this problem
like
out.
a sacrifice.
I'll give you like 2 minutes and I'm gonna go over it.
In the standard deviation of 5 minutes, what is the probability that random select or shifted left? That's only I calculated. That is easy.
Very
You
good.
plug it in, yeah, in the calculator requirement, that's easy. Click.
Oh, same policy as yesterday. The board is yours. Go ahead. If you want, Danny, you could join Carmen on the board and you guys could do it together.
Oh, yeah, we can go. Okay.
Yeah.
Oh, this is great, like you are doing this, yeah, thank you. Really
Mhm.
great, you're probably, yeah.
I told you I would do it for the finals.
Good.
Hmm.
I don't think, like, yeah, if you're not gonna use the calculator, you need to go to the table, yeah, well, you just need to plug it in the calculator. It's good.
Whatever,
It-
whatever you like, no problem.
Yeah, what I do with my calculator, the calculator with this thing, and I just go to step. I don't know, I don't use the keyboard. But second data, not much. In this case is of joining. The standard deviation of five, enter, and then probability like one select all your take less, where it's less, is right tail. No, when it's less, it's left tail. And when it's left tail, is equal to over one. In it's right tail, is lower bound. When it's less tail, when it's right, it's over bound. When it's less tail, when it's right, it's lower bound. When it's less tail, it's over bound. So here it's 15. My probability is 0.15, 0.159. Can I answer the first question?
Yeah, right on the board. I got you.
Or
Yeah, got you.
my first probability is
All right, that's time. Let's go over this real quick. So it says the time it takes for a mechanic to change the oil in a car follows a normal distribution with the mean. Hmm? No, not that one. That's for binomial. Because right, this one says normal distribution, right? Not binomial distribution. So this is the Z.
So I got
Right.
the answer. I don't know if it's right.
All right, so I'm gonna go over it right now. So I have a mean of 20 minutes, right? So mu is equal to 20 minutes, and our standard deviation sigma is equal to 5 minutes. Here's a question. What is the probability that a randomly selected oil change takes less than 15 minutes? So for part A, I want to know what's the probability of less than 15 minutes, right? Which becomes a probability of X less than 15, right? Now remember, I don't know how to do this, so I have to change this into a Z distribution. This becomes probability of Z less than X minus mu over sigma, which becomes probability of Z less than 15 minus 20 over 5, right? We do the math on this becomes probability of Z less than, what's that? Negative 1.00. Then after that, you just look it up, right?
That formula. If you see
Mhm.
how you send me, I have a lot of formula.
But you're not supposed to be on your head. They're on the formula sheet. Don't memorize it. Just copy. All right. So there's a couple of ways we could do this. We could do this in the calculator. We could do this on the sheet, right? So if I'm doing this on the sheet, for example, I'm gonna go to my formula packet. And then I'm gonna go down to where the normal distribution is. You see, it says standard normal distribution, just like the question. I'm looking for negative 1.00. So I go to negative 1, which is right here. And I go to the 00, which is up here.
Kind of question, what is normal distribution here in the formula sheets?
It says it at the top, see? Area of standard normal. Table 3. Look,
Table three?
yeah, look, it says right here, area of standard.
It's not in front.
No, it's the table, Yeah, yeah. So the number I come up with is 0.1587, right? So my answer is 1587. That's for A. You got that? Very good. You got that answer. Let's look at B.
Oh, I got it?
Yeah.
Oh, okay, so I don't have to do all the I was right.
So B says, hey, what's up, man?
Maybe I heard this time.
Awesome. So B says, what is the probability that the average oil change time for a sample of 30 cars? So now N is equal to 30. They come back. All right. What is the probability that the average oil change time for a sample of 30 cars is between 19 and 22 minutes? So they want to know what's the probability of 19 less than X less than 20
Then, Carmen, make it.
to.
So you just need to learn how to use the calculator. That is not another word. You just need to go second data and then, second.
So remember, on our table, we can't look up in between, right? So you have to break it up. So it's going to become probability of X less than 22 minus probability of X less than 19. After that, just plug it all in. It's the same thing, right? Probability of Z less than X minus mu over sigma.
We practice inequalities today.
Yeah, that's what this is, inequalities.
Difficult.
That's what this is.
So,
That's what this is. This is an inequality. All right, so probability of Z, I'm sorry, X bar less than X bar minus mu over sigma over the square root of N. Plug in all the numbers. The mean, which is 20 over the standard deviation, which is 5 over the square root of 30, minus probability of Z less than, what is this? 19 minus 20 over the standard deviation 5 over the square root of 30. A little bit of math. This becomes probability of Z. I'm sorry. So I'm just gonna do this on the side because I assume you guys know how to do this in the calculator already. This is 5 divided by the square root of 30. So I have 2.19089 minus probability of Z less than this is negative 1.09545. Right?
That is for the equal.
But this is showing work.
He made all the steps.
But this is how you show work. In case you have a wrong answer, this is how you get partial credit.
Yeah, but I mean.
1.10.
And calculate it. How I will show you now. So what I did is, okay. If I press, I don't know how you will look it up, but in this calculator, I press second, data, then this.
So I have 219.
Press enter and then I just plug in the mean.
So coming down to my positive 2.1.
Then well, you need to.
And then my 9, this is 0.9857.
The lower bound, yeah. When it's right tail, it's gonna be in the lower bound, and when it's left tail, it's gonna be in the upper bound. And then enter, and then you got your result.
9857. And then
Well, I'm upset because I made a mistake. In the exam, I confused chapter 8
257.
with another chapter.
Okay.
Yes. And because I didn't see this, I didn't pay attention. And I need to pay attention. This is my key. This is my key for the final exam.
Yeah.
This is our key. If we don't have it, we fail.
I told you all the answers was on that. Is equal to 0.9857 minus 0.1357.
He told me you can use this, but this is your key to five.
So this is 0.85.
Okay, I made it wrong. I got 0.235.
No.
It was a mistake. Oh, but you making that the V, right?
The what?
That V, the P19 less time less 22. Inequality now?
Yeah.
Okay, no, I made it over. Oh, my V was good.
Yours should have been in between. That's why you didn't do it.
Had 2 steps.
It's 19, it's in between 19 and 22.
Oh. Oh, okay.
Yeah.
Have a different step to do. Yeah.
All right, any questions on this?
Yeah,
Anybody?
I don't understand.
You don't understand it?
No.
I got you. So you know what? Go up on the board and do the next one.
But I will use the calculator.
I don't care.
Yeah,
Give me the
I will
right
use
answer.
calculator and I will use, yeah, some of the, if I need the formula or the paper, so I prefer to use one.
All right, go ahead. Go do it. Hey, that's okay. I'm happy to see you get pantry. When you get a chance though, put your stuff down and help Danny on the board with this question. Fernando, you could, you could help too if you want.
It is important, I know how to do it. Well, we
So-
also how we made it.
So teach everyone else how to do it. So,
In the calculator, we just need to go, so this is our mean, right? This is our mean. What I do in my calculator, TI 36 Pro, I press second and data, and then I go distribution, and then I go to normal CDF. I plug it in my mean in this case 7.5. 7.5, plug it in, and then my sigma, my standard deviation, sigma standard deviation to is 1.2. 1.2, right? And then I press enter, and then my lower bound, or we need to know first right here, more than, what more than mean?
hey, how are you?
What more than mean? Greater, like bigger, so that means right tail, right? And so right tail is lower bound in this calculation. More than means right tail, right? And then in my low, I will. Exactly, you remember, we work together. We work together, so my lower bound right now is now. And then I let that one upper bound 1E99 for calculator. And then my value is for the first one is 0.1056. My p value of probability of probability is 0.1056. That's for the first one. Then now the other one is what is the probability that the average weight of a sample of 25 newborn babies is less than 7 pounds? So less than the left tail. If it's left tail, where it's going? Where it's going in the calculator? Over bound. In the over bound. Yeah. So I go back, my mean is still the same, my sigma is still the same, enter, and so these right here, less than 7 pounds, but I think my sample is 25, right? So enter, so it's my probability of the average is 0. It's possible to get the same answer.
Mm-hmm.
Really? Okay, I got the same answer. I don't know if it's correct. So my second one, my B, total smarter is not.
Should be doing it on that board over there.
Yeah. Oh, it's my work.
You guys, don't leave him hanging. Help him out.
No, here he is. Perfect. You understand you're gonna make all? Gonna make, I don't know how to do this. I'm going into this same so. We had our test part too.
Okay. No problem.
You might have to buy a. So what do you understand? Ask me a question. So what is the probability that random selected baby weight more than not So what is your mean here? 7.5, right? And your standard deviation is 1 point. So what you take, just do it, make it a calculation. Which one is the word that's in the two plus you are making a hard time in your head.
Go ahead, the meeting. That's good. Just go to the today's one.
If you want to run the table, if you probability. It's chapter 5, if you wanna do in the table, is that right? It's believe. It's chapter 5, if you wanna make it the table,
No, this is 7.
or it's 7. It's 7. Okay. Wanna make. I start.
Or sometimes that.
So you got P, you got PI 36? Oh, yeah, you got PI 30X. Okay, we can try, so clear, go second, we have a second here, second data, and then go to the right. After second and data. Alright. And this is PI 36X roll. It's only $19, you can see.
What do we call
Yeah,
it? So it's the same thing, scrub.
yeah, no, they don't bring out this basic X. Pro.
So,
To make this problem in this calculator, you need to press second in data. And data,
yeah.
and then go to the right. Distribution, then go.
Right.
Yeah, to the right, and then you go to normal CDF. Please, this kind of. Normal CDF.
Wait, that's because of time on.
Oh, no, you should know that. That is another problem. Everything they go, we have time. To make that. It is also available. Normal CDF.
Oh, is that it?
No, so there's a normal two. What one, we know, go. Go.
For test, but is it possible to make them verify us?
Let me ask and see. I'll get back to you. Like, shoot me an email.
Sure.
Yeah,
I could probably do both of them at the same time.
maybe. Then shoot me an email. Shoot me an email. You did recently? All right, I'll check it. All right, I'll check it. I didn't check it. I didn't check it recently yet, but I'll check it.
So this
No, twist 3 was like a couple of questions, like 7. It's not bad. Yeah. It's easier than test 2. Yeah. It's like the probability test. All of that. Yeah. All the probability, like chapter 5, 6, 7. Yeah.
like how long would it take to take test 2 and test 3?
Each one, everybody got 2 hours for each, so
Oh, so it would take like 4 hours
yeah.
around.
Yeah. Is everybody satisfied with that answer? I don't hear no objections or nothing, so I'm assuming that we all good.
Can I have the
Have what?
I have a cat, I'm sorry.
Oh, you show me. I can't see. Oh, Wait, Danny's in the way. Mhm.
Can I have this?
You don't
You
need-
were showing me the keywords.
But you don't need it, it's all on the formula sheet.
Oh, okay.
It's in chapter 3, all of this.
It is?
Yeah.
I didn't know. It was-
And look at the formula sheet on chapter 3, it's all there. There's nothing here that's not there.
And then she put this.
Yeah, we went over that in class.
Can I write that down?
Yeah,
Like on the formula sheet
yeah, go ahead.
when I bring it?
Yeah, go ahead.
Made what? I guess I did the problem.
Yeah.
What is this? Like practice?
Yeah, we are practicing about the finals.
Oh. Oh, yeah, the finals, yes. Mm.
Yes, so we do not know which one you're doing that.
Huh?
The study aid, you don't know which one you're doing yet.
I do know. I'll tell you guys in a minute. All right, so let's look over this real quick.
This is the email.
All right, I got you. Yeah.
Are you recording?
Yeah, I'm recording.
Yeah, you are.
Yeah. But since I already showed you guys how to do it, I'm just gonna do this on the calculator and see if you guys got it right. All right, it says the weight of newborn babies are normally distributed with the mean of 75 pounds, right? It's 7.5, I meant, right? And the standard deviation of 1.2. What is the probability that a randomly selected newborn baby weighs more than 9 pounds, right? So they want to know what's the probability of X greater than 9, right? And then I'm just going to do this in the calculator since you guys already did this.
The TI 84 in the same set on the data too.
Uh-huh.
And then normal CDF.
Uh-huh.
And those three. Like a little different.
It's the same thing. Greater than 9.
For the lower bound.
So 9.
And the upper bound is still the same, 199.
Uh-huh.
It has to be the same, like the mine, but I don't know, I'm not sure the second one because he gave me.
We
the
have
same
7.5. And then we have our standard deviation, which is 1.2.
Yeah.
All right, so I got as my answer
Yeah.
0. Good, good.
Yeah.
So 0.105649.
I wanna.
839.
If four, oh yeah, it's still the same because I have four. You like all the numbers or we can round?
All of it. I don't like rounding.
You don't have any. Okay, that's a good question, you see. Oh, you think, yeah.
But if you are gonna round, give me 4 decimal places.
I prefer to round. Yeah, all right, oh.
So let's see, X bar less than 7, right? So you got that answer good. So X bar less than 7, let's see what that is. All right, go our normal CDF. So it's less than 7, so we have -1 E99. Upper bound over here is 7. Our mean is 7.5. Our standard deviation is 1.2 divided by the square root of, what was this?
It's like one.
25 of 25.
Okay.
Mhm.
I mean,
It's okay. Didn't teach you that in class.
The problem in the second part in the calculator, you have to, when it's less than. You have to press.
So if it's less than, you gotta use the square root.
No,
In all of them.
no. What in the question told me to use the square root? Tell me.
The average,
No. Read part B to me.
So what did you use in the first question? What?
That's my question. Why didn't we use it? What's the difference between the first question and the second question? Read it.
Because the first question is, more than, and the
No.
other question is less than.
Read the question. What's the difference?
it would be selected.
No. And then read the second question and tell me what the difference is. There's a sample in the second question.
Oh,
So anytime you have a sample, that's when you use n.
and in square and the, yeah. The
N-
is square root, yeah.
N is the other formula.
That
Right.
is the difference.
You remember when we have the normal distribution in chapter 7? We have the standard score formula, and then we have this other one called the standard score for X bar. So you use the standard score for X bar whenever you have a sample size.
Well, yes, yes.
Yeah.
I remember.
Okay.
Okay.
So that's what happened in that one.
Yeah,
All right, that being said,
so what's the key word for standard score for X bar, sample?
it is a sample.
Sample.
You see how we have 25 babies that we used?
Mhm.
That's a sample. Okay, here's another question. A random sample of 10 grocery stores was taken to estimate the average price of a gallon of milk. The sample mean was found to be $3.50 with a standard deviation of 25 cents. Assuming the prices are normally distributed, construct a 90% confidence interval for the population mean of the gallon of milk. Okay. All right, so let's look at what we have. We have an N, which is equal to 10. We have a sample mean, X bar, which is equal to $3.50. We have a sample standard deviation, which is equal to 0.25, right? So forget all of that. I just want the confidence interval, all right? So find me a confidence interval. So here we go, right? Now, in order for me to find this confidence interval, I need to have a degrees of freedom, which is equal to n minus 1, which in our case is 10 minus 1, which is 9. Right?
Table 4, right?
Table 4, right? And our confidence level, which I forgot to write down, is 90%, which is equal to 0.90, 0.9, whatever. Our margin of error formula E, which again is in the confidence interval in chapter 8 in your formula sheet, is equal to T critical times your sample standard deviation over the square root of n, right? Plug in the numbers, right? Our sample standard deviation was 0.25. Our n is 10, not 9, 10. All right, n is 10, all right? Times, we got to multiply this by our T critical. So T critical over here.
Yeah, because, one minus is only for DF,
Right.
and then we
Mhm.
just, we put the same word, and, yeah.
All right. So Remember that my T critical is 9, so I have to go to the student T distribution table right here. I'm looking for DF9, which is right here. And then my confidence level was 90%. So I'm looking right here at the top for 90%, right? Going straight across. Now, where do they intersect at? They intersect right here at the 1.833, right? 1.833.
0.9.
0.9 and
then
DF9, yeah.
So DF, they
Mhm.
intersect here, right?
Right?
So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, you're right. So 1.833.
So
Oh, we bring experiment. Experiment is really a country.
hmm. So this is the 1.833. 1.833. Now a little bit of math and you're good to go. All right, let's do this real quick. So this is just plug it in. 0.25 times 1.833 divided by the square root of 10. Here's my number. What happened? What happened?
0.25 is my E, right?
Huh?
After she.
0.25 is S.
E is my S, but my standard deviation, right?
Yeah.
And my E is 0.25. No, my S and my E.
E is what you're looking for.
Oh, okay.
Yeah.
So.
You good, Maria?
Your X bar is 0.25? Can I see the.
X bar is sample mean.
Okay, the sample means 0.25?
No.
Or what is it? What you got here? Can you scroll down, please? Okay, 10 is your sample. 10.
Good?
Okay, man.
Hey, what's up, man? It's good, man. Stick around for 1 second. So this is 0.
You got something for me?
Yeah, just stick around for 1 second. 44911. All right, that's your margin of error, right? Remember that whenever you find a confidence interval, all your answers are X bar minus E, less than mu, less than X bar plus E, right? So what's my X bar? This is the 3.5 minus my E, which is a 0.144911, less than mu, less than 3.5 plus the 0.14491. I trust you all know how to add and subtract. Do that real quick and get me an answer. There you go. You still do test corrections if you like. All right. I'm assuming everybody got that answer. Very good. So this is 3.5 minus this answer. So I got 3.355089 less than mu, less than, let's see what I got, 3.5 plus, whoops. All right, so I got the 3.644911. This is your final answer. Any questions on how to do the confidence interval? Anybody? We good? Y'all all mad quiet. I don't know. Go ahead.
How long is the time?
2 hours. 8. Mhm. These same questions I'm going over. And everybody else is just dazing out. I don't know.
Yes, it's. What question is this?
This is question number. I'll tell you in a minute. This is 7. Mm-hmm. Go on the board and do it. Mm-hmm. Go on the board and do it. Go ahead. Let's see your question. Go do it on the board.
During the lifespans are normally visible, struggling 95 confidence interval for the population in the lifespan, they like bulbs. Find the critical value to find the maximum marginal error, find the lower end point of the confidence interval, find the upper end point of the confidence interval. Who knows this? Hmm? Did you know? Who can stand up and look?
All of you can. Go on the board and do it.
Critical value? You know critical value? You will try, right? You can try. I don't know, you will try.
I just gotta plug in the numbers here, right?
Hmm?
I just gotta plug the numbers here, right?
Yeah, that's it.
Right? This one, not the top, oh, this is how I'm gonna get this
We
one.
always use this one. We never use the top.
Okay.
I don't know why Carmen's working alone. You guys get up or help her. I literally just did an example on the board. It's the same question. Instead of babies, it's light bulbs. That's it. Oh, why is Carmen by herself? Oh, why is she standing alone? We all have the same exam to take. Go up there and help her. Mm-hmm. Hey, it's all good. It's all good. Yo, your whole class just like left Carmen to hang by herself. So sad.
It's about serious?
So go do it on the board.
Are you serious?
Yeah,
Like
so what you gonna
swear
do?
thing?
Yeah, so go do it on the board. Help her out. Help her out.
Are you serious?
Yeah.
Swear.
Yeah, go help her out. Yeah, go help her. Yeah.
The first one I got several, Mr. Lu.
Oh, yeah,
Okay.
I was open in front of Mr. Jude, the whole thing. He was like, what's going on?
That's probably gonna make his whole semester. Mhm. Yeah.
No, I mean, Mr. Lee, I mean, like, it just went boom. And then I have a good bra on because, I gotta make it up.
Mhm.
Yo, and I'm just telling you, I was just jiggling. I ran to Missy Fat's office. I was like this. And Jessica, in the Ivy,
Yeah.
it was like, I closed the door. I was like, and they both started laughing. I'm like, I need help. So she's over here with her little ass fingers like this.
They put like pins or something.
No, ain't no pain.
Yeah.
Nah, I just had too much coffee today. I'm telling you, when I was just sitting there,
Yeah.
the whole thing like, whoop. Mr. June said, what's going on here? Oh my God, that's what took me so long.
When you go home, you probably gonna take a run at the wife now.
Yeah, you probably know who you all use his hair. You already know that. Because it's a sight to see.
Mhm.
Mm,
You don't think you take a run at his wife after seeing that?
Probably, of course.
You know?
I have Mr. Lee steroid, p-value is steroid. My value is steroid.
Your p-value.
No p-value, because here's no probability, I know, but on the first answer I got steroid.
Okay. So what's your interval from what to what?
0.095.
So you see my answer here?
0.9.
Look at my answer. It's in between those two numbers. That's the answer, right?
Yeah, I know.
So
But
we do the same thing here. Hey, what's good, man?
you go. I think both people fighting. Bro.
All right, that's time. Let's go over this question. All right. Good.
On here, right?
Yeah.
Right, we go to this one.
And then find the confidence level at the top.
The confidence interval is 0.095.
Oh,
No?
it's an intervals between two numbers.
Oh.
All right. So let's see. A random sample of 15 light bulbs was taken to estimate the average lifespan. A sample mean was found to be 850 hours with a sample standard deviation of 50 hours. Right? And then assume that the lifespans are normally distributed. Construct a 95% confidence interval for the population mean span. All right? Let's look at what we have. So we have an N. We have a sample size of 15. Right?
Yeah.
We have a sample mean, excuse me.
Of 850.
All right. X bar is equal to 850.
Right.
And hold on, where's my mouse? Okay. And I have a standard deviation
Okay.
of 50, right? This is a sample standard deviation of 50.
Yeah.
Right?
And the X and the alpha also, no, the alpha is different.
No alpha, no alpha. Confidence level is 95%.
Exactly.
It's equal to 0.95.
Exactly.
Right? All right. So now for me to answer this, I have a sample standard deviation, so I need a degrees of freedom is equal to n minus 1, which is 15 minus 1, which is 14, right? All right.
So
Um,
and I looked it up for 14.
Wait, hold on. Our margin of error formula is going to be T critical times the sample standard deviation over the square root of n, right?
Yeah.
Just plug it in. Sample standard deviation is what? Say it again.
Confidence interval is 0.95.
So now let's look up our T critical, right? We have a degrees of freedom of 14 with a confidence of 0.95, right? So let me turn to my formula sheet.
So
You're gonna look in the student T distribution, right? So see right here where it says critical value for student T distribution, right? My degrees of freedom was 14 right here, right? And my confidence level was 90 or 95. Which one?
95. So it will be 2.1.
It was 95, yeah. So go to 95, which is up here.
Yes.
Look at where they intersect that. So what you said?
2.145.
Good. That's it. 2.145. Just plug it in. That's all you have to do. All right. So let's go back. All right. 2.145. T critical is equal to 2.145. A little bit of math. This is going to be what? 50 times 2.145 divided by the square root of 15. Boom. So I got what? 27.69183. After that, remember for a confidence interval, all of your answers are what? X bar minus E less than mu less than X bar plus E, right? This is confidence interval, right? So plug in the numbers. So you have 850 minus the 27.69183 less than mu less than the 850 plus the 27.69183. Exactly. Right?
So what chapter is that? 7.
Eight.
This is 8, yeah.
Yeah.
All right, 8, yeah. Sure.
It is on the formula sheet. Just
Thank
copy.
you. You have to clarify, like when he
Mhm.
S, we use T, right? And when it's sigma, like different, we use DE.
That's true. So let me ask you a pop quiz, right? If I'm going over questions that are on the final and you never seen me use sigma, what do you think is coming on your final? Right. Mhm.
I wanna ask you
Mhm.
one question.
Mm-hmm.
Well, we're not working on that right now. But you know, oh wait, this is like, you know, it's like it's 4 steps to.
The hypothesis test?
Is that gonna be on?
Yep. Mm-hmm.
Wow.
And that's it. All right. Any questions on the confidence interval? All right. Let me see how much I got left. Oh Lord, I got 2 more questions left. Jovine, can I do these 2 questions real quick? Thank you. Appreciate you. All right, since I'm over time, I'm gonna do these 2 questions like lightning fast. So pay attention. All right? Don't worry, it's being recorded. You could play it back. All right? Probably on Friday. The video from yesterday just finished downloading right now. Sad. It'll be posted like tomorrow. Yeah. All right, 2 more questions, real quick. So a manufacturer claims that the light bulb, excuse me. Let me get my highlighter.
Now, lifespan of 1,000 hours.
Mm-hmm.
Full.
Yeah. So a manufacturer claims that their light bulbs have an average lifespan of 1,000 hours, right? A consumer advocacy group wants to test this claim. They randomly select 25 light bulbs and find that their sample mean lifespan is 980 hours. With a sample, excuse me, Mhm. Of 50 hours. Thank you, thank you. All right. Assuming that the lifespan are normally distributed, test the manufacturer's claim at the 0.05 level of significance. Hold on a second. Mm, 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 mm. Hang on a second. Forget that question. Because that's not a good, it wasn't posed correctly. All right, I'll give y'all another question like that later. Just let me do this next question then. There will be a hypothesis test question on there, but it won't be like that one that I just read. So real quick, let's do this.
Consider the power of simple.
Right? So we want to make a scatter diagram. Everybody remember how to do this?
This is that big.
It's easy. It's that. Why are you grabbing your calculator? You can't do no scatter diagram with no calculator. What are you grabbing your calculator for?
Oh, X and Y.
Yeah.
That's all right.
Hmm.
You read this?
No, like why?
Everything, all that possibility.
I don't know, for me, I mean, yeah. I don't know.
So look, for our x's, right, we're going from 10 to 30, right? So I'm going to skip a few numbers. I'm going to just start off here at 10, right? Maybe I go up by fives, right? 10, 15, 20, 25, 30, right? Those are my x's. Now, listen, you're going to have some kind of story on your exam, right? X is going to have a name, right? Like baby butterflies or something. I don't know. I'm making it up, right? Whatever the name of your X, you write the name right here in the story that they give you, right? I don't have no story, but make believe that there's a story, right? Same thing with Y. Y is going to have a little name thing right here too. I don't know what it is, but let's call it sunshine. I don't know. I'm making it up. Anyway, yeah, that's it. So for the Y, right? I'm going from 25 up to 50, right? From 25 up to 50, right? Let's say I skip a few. Let me start off at like, let's say 20. I want to go up by tens. Let's say 20, 30, 40, 50. It's up to you how you do your bounds. It's up to you how you increase it, right? Just make sure you label it correctly, right? After that, just plot the points, right? So this is 1 point here. I have 10 and 25, right? So I come across to the 10, go up. So I'm coming across the 10, and I'm going to go up to where I believe 25 is, somewhere like right there. All right? You know what? Let me change my colors. All right. There. Next point, let's see what next point is, 15 and 40, right? So I'm coming across the 15, going up to 40, right here. Next point I have is 20, 35. So I'm going across the 20, going up to 35. Next point I have is 25, 50. So I'm going to 25, going up to the 50, right up here, right? And then I have 30 and 45 right after that. So go to 30, going up to 45. All right. That's your scatter diagram. All right. Next, part B. Based on your scatter diagram, what would you estimate the correlation coefficient to be? Positive, zero, or negative? Positive. Very good. Right? Because the trend of these points are all increasing. Right?
Yeah, no.
Mm-hmm.
So why is positive? Why? Can you explain?
You tell me. Why'd you say positive?
I just guess inputs, right?
What made you guess that? Right. So you read graphs the same way that you read books from left to right, right? So from left to right, this trend line is increasing, right? So we would estimate this to be positive. If they ask you for an interpretation, what would you say? So you would say as X is increasing, Y is increasing, right? That's positive. If it was negative, as X is increasing, Y is decreasing, right? What do you want to see, the table? All right.
So we just have to make a graph that's it.
Make a graph, and then you have to tell me what do you think the correlation coefficient would be, positive or negative? The correlation coefficient, do you think it will be positive or negative?
Positive.
Or negative? Yeah.
Graph.
Then you interpret it, huh? One graph, yeah.
And then we have to interpret.
Mm-hmm. So here, you guys try while I find you a better hypothesis question.
Okay. What's the name of the graphs? You said right underneath.
There's going to be a story on your test that's going to give you it. You write those names in. Hmm?
We don't have to start with zero, correct?
Nope, up to you. If you want to, yes. If you don't want to, it's okay. Yo, somebody do this on the board real quick so I can just say yes or no. Well,
Okay, so
yeah, draw it. Hey, you don't want to draw it. Fanta, go draw it for me. Go draw it on the board for me.
you want the graph?
Yeah.
Okay.
Alright, I'll answer it.
Additional.
Mm-hmm.
Sometimes when, yeah, I mean, well, we don't go on, well, we do it to stop, you know, reason, you know. Okay, so, you're gonna do an X, right, X. And then you're gonna do that. Okay. No, that's. Okay, we got that, okay, we got that over there. No, I know, but I was just writing it off, like, oh, you guys are advanced, I'm sorry. Okay, yeah, okay, so. Five. And then 10. 15, 20, 25. Okay, 25. Okay, and then for Y, 1.
No, 12. 8,
Uh-huh.
5, 3, 1.
5. And then, okay, that was the last. All right. So on top, we're gonna do
25.
no, it's supposed to be 12, isn't it? It's supposed to be 12. This, yeah. Okay. Maybe. And then you know, it's gonna be the five. And.
I didn't do it, but I trust you guys that you guys know how to do it.
Okay, now, follow that one, 12, boom, there it is. Boom. Ten is that one, 2. 75, 5. 18 is that one, 5. 20 is 9. Sorry. Now, this is going negative. Why this is negative, right? I'm gonna say exit.
So, well,
Because he said it's like a boat from left to right.
so, why is he saying X and
No, they're supposed to do it at the same time.
How did a histogram get up there?
It's not missing, that's not.
It didn't say scatter diagram? No, that's a histogram, scatter diagram.
Oh, with the X's. Oh, my fault, my fault.
Like literally copy me. Like I'm literally looking for the same thing. You know?
Then I took my time to go and say, you see that? Okay. You shot sir, you heard it. Oh, 1, 2, 3, 4, 5. Okay, so now since it's going to the left, it's decreasing, so.
Would it be Y
So if it's decreasing, so as X is increasing, Y is decreasing.
So if I want to set it backwards, do you see what's wrong?
As long as you put the X and the Y in the right place.
Okay,
Yeah,
but
yeah.
it's-
Yeah, that's fine.
So wait, so Y is decreasing?
Yeah, Y.
X is increasing.
Yeah.
Okay, this is what I'm trying.
If the increasing is positive.
Y,
It's
Mhm.
negative.
10,
Oh. Ain't it negative?
3,
Huh?
Ain't this a negative?
It's negative.
X is increasing, Y is
Decreasing, right?
Okay, well, I is decreasing. So now,
That's it.
we have to say is it positive or negative, but
Which one is it?
negative.
Good, that's it. All right, next question.
All
All right. A smartphone company claims that the average battery life of its latest model is 20 hours. A tech reviewer wants to test this claim. The population standard deviation sigma is equal to 3, right? And we have mu is equal to 20, right? A reviewer randomly selects 36 phones, and it's 36, and finds that the sample mean, X bar, is equal to 18.8 hours. Assuming the battery life is normally distributed, test the claim, right, that the company's claim is at the level of significance alpha is equal to 0.05, whatever, right? Cool. So let me ask you then, right? What is your null hypothesis? What is your alternative hypothesis?
Okay, because on average, I think it's 212.
It's two-tail. Cool. So mu is what?
Equal when they.
Equal to what?
The mean population, in this case, population mean. What is the population mean in this case?
You tell me.
Alright, I guess it's as more like the average for life, I think it's 20.
20. Okay. All right. So the alternative hypothesis is mu is.
So, and 20.
I agree. It is two-tail. All right.
So,
But
for average, I know.
but for my sanity, I'm gonna call this less than 18.8. All right.
Oh,
I mean less than 20. Excuse me.
I am not to tell.
It is two-tail. You're right. I just want to do an example where it's less than.
Oh.
Right. But you're right. Because they didn't actually tell you that the claim was less than or greater than, right? So it is two-tailed, it's different, right? But I want to do an example for less than, right? Your test will be either a less than or a greater than. It will be clear. They will tell you. All right. Anyway, right? What kind of test is this?
Okay, wait, so no one knew this.
Mm-hmm.
This is a Z test.
Good.
Ooh, yeah.
How'd you know it was a Z-test?
Because no one knew is
You know what sigma is, right?
sigma, sorry,
Okay.
it does switch around,
It's okay.
but
Also, did we ever talk about a test that wasn't sigma?
no, that's the T test though, so.
Exactly. We never learned that, right?
No.
So on your test it's gonna be a good, all right? That's it. All right, just plug in the numbers. All right. So we're gonna have 18.8 minus the mu, which is 20, over sigma, which is 3, over the square root of n, which is 36.
Please, when we have to plug it in.
Yeah, just plug it in.
I get like, I see it like this, and I know I have to plug it in, but I get like,
I got you.
I anticipate.
I got you.
So it's always in the test, it's gonna be a Z test.
All the time it's each side.
Not all the time. On your final, it's gonna be like that.
That's
Don't be going into the real world, be like, oh yeah, all testers eat. No, they're not.
And, okay, so can you when you insert the numbers, can you do that again, please?
What do you mean?
When you set it up for the formula.
So I just copied the formula from chapter 9 in the formula sheet, and then I have all the numbers here, X bar, sigma, just plug them in. That's all. Yeah. From the story. Okay. Yeah.
No, I know, but I'm saying.
You know, but it's just too, you forget what each number stands for, like, it's the,
Mhm.
the, you. Yeah, I have that.
That's why I make a bank of it and I just pull from the bank, you know? Like this is a bank, right? And I just pull all the numbers as necessary from there.
Yeah.
Mhm. Mhm.
No, the,
Mm.
which is the X bar, when you like pulling those numbers
Out of the story. Got you. So for the story now, right? On your test, they're gonna be very, very clear. They're gonna say X bar equals this, sigma equals this, right?
We're not going to guess with this.
No.
Oh,
No.
So my p-value is bigger.
It's Microsoft Copilot, that's why. You know how that be.
P-value is bigger, we do not reject the null hypothesis.
Correct.
Wait.
And you'll receive super partial credit for just writing that. All right. You said thank you. He didn't even think about what I just said. Wow. I didn't say full credit. Yeah. Because I already know. I already know you're not writing this. I already know that. You're not gonna write that. I know that. You do have to write it, but you're not gonna write it. I know that. You're not writing this. That's partial credit too. Right? Everything you see me do, you copy me. Copy me. Don't change nothing. Go ahead, sir. Probably tomorrow because it takes time to download. Yeah. All right. So after you have your Z test, right? Then we want to find our p-value. Right? Your p-value is the probability of your Z test. Right? What's the inequality symbol?
This equal with the slash.
What's on the board?
0.05.
Oh,
2.4, negative 2.4.
So what symbol is this with the equal and
So
the
look.
slash?
Whatever your alternative is, right? That's what your inequality is going to be right here. Just copy. Don't make it up. So all you got to do is copy. All right. After that, look it up in your table, right? You have negative 2.4. Don't mind me. I know y'all all know how to look this up already. Time is against me. That's why I'm doing this like this. All right. So I got 0.008198. Okay. Now that you got your p-value, then you're going to do your p-value versus alpha, right? So this is the 0.008198. Alpha was what? 0.05. Which is bigger?
Like from the chart, negative 2.
No, alpha was given in the story. Yeah. The answer we get from the chart is this answer, the p-value. Yeah.
Then the negative 2.4 is
The Z
the
test, the Z formula. When we plugged it in, that's what we got. Which is bigger, the p-value or alpha? Good. So if my p-value is less than alpha, what would Snoop Dogg do?
We reject,
Something with the whole.
Right?
rejected null hypothesis.
So I reject
The null.
HO, right? You see this right here? This is another point, right? Then you have to interpret it, right? So yeah, you can. So there is enough evidence to reject, how you spell that?
R-E-J.
Right? And that's another point right there. I want to see all of this. This is full credit. All right?
Reject, there is enough.
Evidence to reject the null hypothesis.
That's
It's easy, right?
Easy.
All right, so listen, this last question, take a picture, bring it to tutoring, whatever, all right? Because I done took up so much of Jovine's time.
Take a picture, bring it to tutoring.
Yep.
Hold on.
This is the,
Oh. That's smart. Oh.
if y'all give me a few minutes, I'm about to finish y'all test 3. All right,
I've got a problem, so because I told you I have to do something right.
You don't want-
By mistake.
you don't want to wait for test 3? All right, that's
Oh,
fine.
the test three?
That's all right, go ahead.
Oh, I thought you say like you lost time to finish the check.
I'm gonna give you back test.
Oh, you get wait
Yeah.
work. I was the person who waited.
Do you want to use a board? Something?
Oh, shit.
Everybody got a picture? Yeah. I don't have time to go over it. Y'all could bring it to tutoring or whatever.
No. Well.
Can I take it down? Thank you. Love y'all.